Mars is often called the red planet. But why? What makes it look so red? The answer lies in its dust. Mars is covered in dust filled with iron oxide. Iron oxide is basically rust, and as we all know, rust is red. This rusty dust covers almost the entire surface of Mars. It gets kicked up into the atmosphere, making the planet look red even from Earth. The redness of Mars has fascinated people for centuries. It makes Mars stand out in the night sky. Ancient civilizations associated Mars with war and bloodshed because of its color. Today, we know Mars is a much more complex and interesting world than its color suggests. But the name Red Planet has stuck. It's a reminder of the power of simple observation. Mars is smaller than Earth, but it's still a pretty big place. Its diameter is about half the size of Earth's. If you were standing on Mars, you'd feel much lighter than you do on Earth. This is because Mars has weaker gravity than our planet. A day on Mars is surprisingly close in length to an Earth day. It lasts about 24.6 hours. That means you could keep your earthly sleep schedule on Mars with only a little adjusting. However, a year on Mars is much longer than an Earth year. It takes Mars 687 Earth days to orbit the Sun. That's almost twice as long as our year. Imagine celebrating your birthday every 2 Earth years. That's what it would be like to age on Mars. These differences in size and time are important factors to consider, especially if we ever want to send humans to live on the red planet. Unlike Earth, which has one large moon, Mars has 2 small moons, Phobos and Deimos. These moons are named after the Greek gods of fear and panic. The names are fitting because these moons are small and oddly shaped. Phobos is the larger of the two, but it's still tiny compared to our moon. It's so close to Mars that it orbits the planet faster than Mars rotates. That means if you were standing on Mars, you would see Phobos rise in the west and set in the east. Deimos is even smaller than Phobos and orbits much farther away. It looks like a faint star in the Martian sky. Scientists believe that both Phobos and Deimos are captured asteroids. They were probably drawn in by Mars's gravity billions of years ago. Mars might be smaller than Earth, but it boasts some of the most dramatic landscapes in our solar system. Take Olympus Mons, for example. It's the largest volcano in the solar system, 3 times taller than Mount Everest. Then there's Valles Marineris, a canyon system so grand it makes the Grand Canyon look like a ditch. This enormous canyon stretches for thousands of miles across the Martian surface. These features tell us that Mars was once a much more geologically active place than it is today. Besides these giants, Mars is also home to vast plains, towering mountains and polar ice caps. It's a world of incredible diversity just waiting to be explored. One of the biggest challenges to exploring Mars is its atmosphere. Martian air is extremely thin, about 100 times thinner than Earth's. It's mostly made up of carbon dioxide, which is poisonous to humans. This means that humans on Mars would need to wear special suits to breathe. The thin atmosphere also means that Mars doesn't hold heat very well. Temperatures can swing wildly, from a balmy summer day to a frigid winter night. The average temperature on Mars is a chilling -80 degrees Fahrenheit or -62 degrees Celsius. That's much too cold for humans to survive without specialized equipment. The thin Martian air also makes it difficult for liquid water to exist on the surface. Although we have evidence of water ice, any liquid water would quickly evaporate in the thin atmosphere. This is just another challenge we'll need to overcome if we ever want to make Mars our second home. Section 6. Water on Mars. A history written in rocks. Even though Mars is a dry desert today, there's plenty of evidence that water once flowed freely on its surface. Scientists have found ancient riverbeds, lake basins, and even signs of past tsunamis. These features tell us that Mars was once a much warmer and wetter place than it is today. The question is, where did all that water go? Some of it is locked up in the polar ice caps, but much of it may be trapped beneath the surface as groundwater. Scientists are eager to find out if liquid water still exists on Mars. Liquid water is essential for life as we know it. Finding it on Mars would be a major discovery. and it would greatly increase the chances of finding evidence of past or even present life on the red planet. Section 7. Life on Mars? The search continues. The possibility of life on Mars has captivated humans for centuries. It's a question that drives much of our exploration of the red planet. While we haven't found definitive proof of life on Mars yet, we have found tantalizing clues. For example, we've discovered organic molecules, which are the building blocks of life. We've also found evidence of methane in the Martian atmosphere, which could be a sign of microbial life. These discoveries don't necessarily mean that life exists or existed on Mars, but they do give us hope. The search for life on Mars is one of the most exciting scientific endeavors of our time. If we were to find evidence of even the simplest life forms, it would revolutionize our understanding of life in the universe. Section 8. Exploring Mars from Flybys to Rovers. We've been exploring Mars for decades, sending spacecraft to orbit the planet, land on its surface, and even rove around its dusty plains. The first successful mission to Mars was Mariner 4 in 1965. It performed a flyby, sending back the first close-up images of another planet. Since then, we've sent dozens of missions to Mars. Some of the most notable include the Viking landers in the 1970s, the Sojourner rover in the 1990s, and the Curiosity and Perseverance rovers currently exploring the surface. These missions have taught us a tremendous amount about Mars's geology, atmosphere, and potential for life. Each mission builds upon the knowledge gained from previous ones, bringing us closer to understanding the mysteries of the red planet. Section 9, Mars Awaits, a future for humanity. The idea of humans traveling to and even living on Mars is no longer science fiction. Space agencies and private companies are actively working on making this dream a reality. The challenges are immense, but so are the potential rewards. Imagine humans walking on Mars, conducting research, and building the first settlements on another planet. It would be a giant leap for humanity, expanding our horizons and challenging us to innovate and explore like never before. The journey to Mars will be long and arduous, but the spirit of exploration that burns within us will surely lead us to the red planet. And when we get there, we'll be ready to uncover the secrets that Mars has held for billions of years. Mars awaits.